Thank you everybody for listening to my talk about the Vplan kit, a Linux-based open source 6Lowpan IoT PSP. My name is Alexander Ahring, and let me start. Why you are here? I want to remember you. Here is the FOSDEM website banner on the index HTML of FOSDEM.org, and there stands a lot of buzzwords like beer or hackers with lectures. And when I heard the first time about the FOSDEM, I thought about everybody is something like hackers with using beer with a lot of talks. And you can do that, that's fine for me, but when I look at here in the audience, nobody is like this guy, and you're not here, I think, because you want to only drink a lot of beer and missing a lot of talks. You are here more because you are hackers which looking for the next challenge, which you look like to make as a big project with which you want to do. And my personal challenge at Penguintronics is IoT 6Lowpan. I'm the Linux kernel maintainer for the 6Lowpan branch inside the Linux kernel, and my tasks are managing patches, review, and talking about future plans. And I also did the last FOSDEM talks about my 6Lowpan stuff inside the kernel. And I also, on the mailing list, I'm helping a lot of users. And the users asking many times how to use the 6Lowpan stack on the Linux, and how to do the kernel stuff and cross compiling if you run it on a Raspberry Pi, and do all other stuff. And for example, for the Raspberry Pi, they replaced the Raspbian image with a mainline kernel, not the RPI kernel anymore, and then all running in the same issues. For example, if somebody knows the if block D daemon, the task of this daemon is to bring the interface up again if somebody does our interface down. It gets some features, and a lot of people have this issue that they can't change some attributes in the interface because the interface needs to be down, and the daemon does it up when you want to drive it down, and that's some feature of Raspbian. And I also do a lot of lectures like this one here, and yes, I also talk about the Raspbian Pi. Here, for example, is a 802.54 transceiver. You can get this transceiver from Open Laptop CEO. It's open hardware, okay, except the transceiver here, but the board itself is open with some schematics. And the Raspberry Pi is the Swiss Army knife. It's one Linux, and it's easy hackable because the pin is here, and it's really cheap. I think everybody here in the audience has a Raspberry Pi. And my Vplan kit is a board support package. Board support package is it helps you to realize your next Linux-based challenge. That means it does a lot of cross-compiling, the bootloader, the kernel, the user-based software, and at the end we have a final image. So you don't need to replace the running kernel from your Raspbian anymore. Simple check out the Git repository for the Vplan kit, then type some shell command, and at the end final image will be produced, and you can flash it on your SD card, and it's simple, runs everything, the bootloader and the kernel with special 6Lowpan enabled features, and user-space software which is needed for 6Lowpan and IPv6 stuff. So 6Lowpan, if nobody heard about it, it's IPv6 over low power wireless personal area network. A low power wireless personal area network is something like 802.15.4 or Bluetooth Low Energy. That's some low power wireless personal area networks, and it's also used by some small IoT operation systems like Contiki or Wired OS, which runs on small microcontrollers, and it means that your thing, which is connected by some microcontroller with Contiki or Wired OS, get an IPv6 address to get access from any IPv6 connection. So then I was thinking about if I'm maintaining a Linux subsystem and many users have these issues with the Raspberry image and the if-plug-D, providing a development kit would be great because nobody has the issues anymore. It's you need only to type a command line command, and it will generate you everything to run 6Lowpan on the Raspberry Pi. So Linux 6Lowpan, what we currently support is Bluetooth Low Energy and 802.15.4, and a typical use case are something like a border router that's for routing from Ethernet IPv6 network into 6Lowpan network, or a simple one as client, as a central node for measuring some temperature or other stuff, and you also can do it for testing. I heard about that in this dev room is a lot of IoT software presented, and if you have IPv6 connection for your IoT software, you can simply test it if your IoT software works with the 6Lowpan stack or the Linux. And you can also use it for developing. I use it myself for making mainline 6Lowpan stuff, and we have also some users which wants only have some great monitor device, like with this transceiver and Ethernet. You can run Wireshark on your desktop PC and pipe over Ethernet the Wireshark traffic over network, and display it on your desktop PC. Yes, the VPN kit use some components like the Ovelas tool change and PDX-Disk. PDX-Disk is a tool, a build system tool, which does a lot of cross-compiling stuff for you. It also offers interfaces for auto tools or CMake to make the right environment variables to cross-compiling your stuff for the Raspberry Pi, for example, and also use Barebox, that's a bootloader for Raspberry Pi and Raspberry Pi 2. We support the platforms for the VPN kit, which is the Raspberry Pi 1 and the Raspberry Pi 2 and the BeagleBone, and for QEMU we have some x86 emulation, and I personally use it only for USB because fighting this USB on the mainline state for this Raspberry Pi is very difficult. Sometimes it works, sometimes it doesn't work. And you also can do a virtual interface. We have some fake ALD driver. The name is fake ALD for fake loopback. It's similar like the 802.11 wireless hardware simulator driver, if you know this. And you also, that means you don't need any special hardware to test your IoT software for the 6Lowpan stack. You can also test it with the virtual driver. So you can get the software on this website. It's the website from the Linux WPAN project. And we also have some tables here outside where we presenting Fairbox and PDXs, and it includes also 6Lowpan and co-op demonstration. It's directly here in this building. Are there any questions?
Speak louder for the whole room.
Right, I'm reading that there's a new Bluetooth specification coming along, which makes some changes, which might help drive 6Lowpan. Increases in packet size and that type of thing. Do you think that's the case, or do you think that's a red herring? How old are you for that?
Yeah, I'm not a Bluetooth expert, but I also heard about they want introduce more meshing into the Bluetooth standard and not any more point-to-point connection. But I don't know. I think it will be similar like 802.15.4, because 802.15.4 is they have broadcast frames and other things, and they want to make it more in touch stage to make it more happier with IPv6, because we have multicasting and something multicasting over point-to-point connection are very harmful. But I also heard they don't want to do this in 4.2. It's delayed. Yeah. But they want to do this for the special use case as a program. Okay. Any other questions?
What about routing?
Okay, what about routing? You can use IPv6 routing, but you don't want that because 6Lowpan is very lossy networks.
For 6Lowpan exists RPL protocol?
Yeah, yes. The RPL protocol is defined by the wall group. It's from the IETF. There exists a user-space application on Strong. I didn't test it yet, but it's on my to-do list for the next part. But you can also use IPv6 routing, but it's not very. You don't want that because IPv6 routing is made for Ethernet cable connection, which is very stable, and but you can also use it as border router for one hub connection.
So currently you use border router and star network around it. You don't provide
no routing for border router use case, but it's still on the to-do list, and we have maybe a RPL border router.
Do you test connection with our quantity?
Yes, yes, it's working well between
Are you planning on routing? Are you planning to do this? Are you choosing for IP routing or like mesh under routing?
Mesh under is doing routing on the link layer, but for 802.15.4 this doesn't exist from the standard.
somebody to.
Yeah, you can do that, but then you are incompatible with the rest of IoT world. RPL is one of the defined standards, and when I say I want to test it, I did the Armstrong implementation. The name is Armstrong, and I want to test the implementation. I didn't test it yet. It's on my to-do list. Any other questions?
So I've developed some standard Linux Wi-Fi mesh routing protocol. I help with some other ones. I've organized the battle mesh as well, which is happening in April or May. So my question is, how deep can you change things into the mesh of the 6Lowpan of the stack? Because on Linux we have this problem that you can build your own metrics depending on the condition, the RF conditions. You can insert new metrics in function of the temperature if you want, funky things like that. So I was wondering, can you really change every bit you want into the mesh stack? Like doing funky things with routing, like I have an algorithm that decides, okay, I take that route because I want to.
I think this is very specialized for the special routing protocol for lossy networks, because they handle the right routing, and the IPv6 routing doesn't. It isn't made for lossy networks. For example, some node is damaged and you can't exit it anymore. It's.
But can you change the algorithm behind the mesh protocol? Can you do that if you want? Can you do it? Is it possible with your solution? Or it's defined by one vendor or one standard that says that's like that?
Yeah, I think what you're searching for is the RPL implementation.
Okay.
And mesh network, you mean mesh under routing, or?
At the lowest level possible, like RF or typically the typical problem is to get information from the RF part to the upper
like the
level.
receiving signal range.
Yeah.
We need to introduce some more
data from the physical side.
Yeah, we need more interfaces to ask a driver about received range. Then RPL makes some matrix calculation about that, and yes, then they calculate if the signal is good or bad.
Typically, the issue we have with drivers to get information from the driver. So I don't know if it's the same issue with 6Lowpan. Do you get everything, or there's some information you cannot get from the...
You don't talk 6Lowpan directly with the driver layer. You have a link layer.
The audience, please, because we have a whole room of people here. You can talk together afterwards.
Okay, I talk with you later. So, any other questions?
No, we can close.
Okay, Alexander, thank you very much.